Hello everyone, this is Ashish Saini from Innovate Yourself. Welcome back to my channel. Once again, I am back with another video on machine learning. Like in a previous video, I have already shown you that how you can use the first classification model, which is the k nearest neighbor. Similarly, in today's session, we are going to talk about another machine learning model, which is for the classification, and that is named as Navier. So this is all that we will be covering in today's session, and also we will see the practical implementation of Navier's theorem. So now let's understand what exactly Navier's theorem is and how to use Navier's theorem practically. So let's get started. So what is Navier's theorem, or let's say what is Navier's algorithm? So it is a classification technique based on Bayes' theorem with an assumption of independence among predictors. So in mathematics also you must have studied this algorithm if you have the mathematics in your 12th class, right? So there you must have learned about the Bayes' theorem and you have an idea like how it is actually working. But still, if you don't have an idea, that's not a problem. I will give you an idea that how you can use the Bayes' theorem in the algorithm which we are going to use in here. So before going directly to the practical implementation, we will see what is the mathematics behind the Navier's theorem, right? So this is all that we will see. And in simple terms, a Navier's classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature, which means this is totally independent and it doesn't have to do with the first feature, or let's say on prediction it doesn't require any other feature for the prediction purpose, right? So this is all that we will be doing in here, and we will see how it works and why it doesn't require that, right? So for that, first just see the formula that is used over here, or let's say this is a formula for Bayes' theorem in which you have the posterior probability, likelihood, class prior probability, predictor prior probability. So this is all that we will be having, and based on that we will be having a data set, and that data set will be used, that data set will be applied in the formula, and based on that you have a probability and you can say, yeah, this is a probability that this event will occur. So this is how we will see that part. And now let's understand this part in details, like what exactly this formula is and how it actually works. So to make you clear about that, let me just open the Excel sheet so that I can explain it to you in a more and a proper way. So let me just open it first. Alright, so you have an Excel sheet opened on your screen. Now let's understand what exactly it is, right? So let me just magnify this first, right? So for that, firstly let's understand that we have a data, right? So for example, I'm going to add a few data in which I will be having two columns, and two columns will be having two features. For example, first we'll be having the information about the weather, second will be having the information about the match that will be played on that particular day or no, right? So this is all that we'll be having. So let me just add the data here. Alright, so this is all that I have done. I have added a data. I have this small data with me, right? So in here, let's say this is a complete data with me. This is a complete information that I'm having right now, right? So let me just okay, anyways, this is a small data which I'm having in here, where I'm having two features. One is weather and the second one is play. So let me explain it to you what exactly it means. It means like this is a weather, like for example, I'm talking about today I'm having a sunny weather, right? And on that sunny weather, am I playing the match, right? So this is the information. So the information is no, I'm not playing a match. So this is how, similarly on the overcast day, on the rainy day, I'm having the information, and based on that I have yes or no. So on the basis of this yes or no, I will be calculating the probability that whether I'm having a probability of playing a match on that particular day or no, right? So this is all that I will be doing right here, right? So this is the complete information that we have, and for applying a Navier's theorem, for applying a Bayes' theorem onto this data, what exactly we have to do is we have to first create a frequency table for that, right? So firstly, in Bayes' theorem, what happens is we will create, not we, if in case we will say simply, if in case we talk about general term, if in case we are going to do it manually, then we will create ourselves. Otherwise this will be done in the backend by your algorithm which you will be using, right? So firstly, after you have this data, the frequency table will be created based on that, right? So let me just create a frequency table for it. So let me just add the information over here. So let's say frequency table. Similarly, now I have to tell the information like what is the occurrence of sunny, what is the occurrence of overcast, what is the occurrence of rainy. So I will be adding all of them over here, right? So just add it. Similarly, the probability of yes or no, right? And let me just shift this below, because one more column will come here, which is weather, right? And here this is the probability of no, this is the frequency of yes. So this is all that I've done. And at last, the last thing is I will type the grand total. Let's say it's a total, right? Now how many times sunny weather I'm not playing? So I mean I have to calculate the frequency for sunny. It's like I have all the probability for this only, right? So let me do one thing. Let me just change one of it to yes also, right? Okay, so this is 3 now, and similarly this is 0, right? Just because I don't have any yes for sunny weather, right? So this is what I have done. Similarly do it for overcast and rainy as well. So let me just do it quickly. Alright, so you can see I have the data with me. Now just do the grand total of it and accordingly just write it, right? Let's say this is 5 and this is 7, right? So this is how I have the complete information with me, right? So I have the complete data with me. Now accordingly, what next I have to do is, if I am going to do it manually, I will have to create a likelihood table for it, in which I will be having the probability for all the conditions, whether let's say I'm having a probability of playing a match on a sunny day, whether I'm going to check a probability of total yes, probability of total no, probability of overcast, or everything. So I'm going to check all the things, and let me just create a likelihood table for that. For creating a likelihood table, so you will have the data something similar to this only. The only difference is here I will type likelihood table, and in here what we will do, I will simply calculate let's say the frequency for this. So what is the probability of occurrence of no? So it's equal to, let's say 5 is the occurrence out of 12, right? So this is the occurrence of no, right? Similarly do it for this also, right? So in this way we have this. Similarly, I have to check for the overcast, rainy and sunny, 3 of it. I have to check for all of it. So probability of this, and this is the total probability which I am calculating for sunny. So it's 3 plus 1, 4 divided by 12, right? Similarly do it here also, 4 divided by 12. I'll leave it. Anyways, doesn't matter, but I will have the same value in all the cases, right? Okay, so I'm having the same value in all the 3 cases, right? Just because here 1 and 3, 1 and 3, 3 and 1. So this is how I'm having the ratio, where this is how I'm having the frequency of the weather and the play, right? So this is all that I'm having in here. Now when I'm having the data with me, when I'm having the probability of all the things, I'm having the likelihood table for it. Now it's time to calculate. It's time to use the formula. It's time to use this formula for the Bayes theorem, based on which I will be calculating like how many chances are there that I will be playing on a sunny day, right? So this is all that I have to calculate. So for that I will be applying this formula, and for that what next I have to do is I have to calculate my formula in such a way. And to calculate it, firstly, for example, what I have to calculate, let me just type it here. For example, I want to calculate, let's say, probability of yes, okay, yes on a sunny day, for example, right? So what will be the probability for this, right? So this is the value which I have to calculate from here, right? similarly for this, as per the formula, you can see I have two other values which I can have. Like for P of C of X, I must have these three values. First is the likelihood value, which I have calculated. Second one is class prior probability, which I can calculate. Similarly, the predictor prior probability, so I will be having that also. So this is how I will be calculating it, and now I have to apply it in the formula, right? So let's say I'm having a value, let's say probability of Sunny on yes, right? It means like I will be playing on a sunny day, right? So this is the probability for that, and I can calculate it from here, right? So that's not a problem, that's not a big deal for us. Multiply by probability of a yes, right? Probability of a yes, right? So this is all about it. Now divide by what is the probability of a sunny weather, right? So this is all that I will be doing here. Currently it will not show you the output just because I haven't put something wrong, right? That's not a problem for me. Okay, anyways, so this is how we have done this part. This is a formula for us. Now let's put the values one by one, but before putting the values, let's calculate what is the output for this. What is the values for P of Sunny of yes, probability of yes, probability of Sunny. So let me calculate that first. Firstly, let's calculate the probability of, let's say, Sunny of yes. So this is what I have got calculate. So for that, what is the probability of yes on a sunny day, right? So for that, the value will be how many yes you have on a sunny day. Okay, so you can see on a sunny day I have only one yes, right? So it will be like one yes, right? And what is the total number of yes? Total number of yes is 7. So this is how just change it. Let's do it like this, equal to 1 divided by 7, because the total number of yes that we have is 7. So this is the first value. Okay, so you have the value. Similarly, let's calculate the value for yes also. What is the probability of having a yes? So let's say P of yes is equal to, what is the probability of a yes? Probability of yes is this, which is 7 divided by total number of values, which is 12. So this is how we have this value. Similarly, now last thing which we have to calculate is probability of a sunny weather, right? Now what is the probability of having a sunny weather? So the probability of sunny weather is, what is the total number of values? 3 plus 1, 4, equal to 4. What is the total number of values? Divide by 12. So its total is 12, right? So this is how we have these values. Now the next thing is that we have to calculate this, which is this. So we have to calculate this. So how should I calculate that? So calculating that, I need equal to, first one, what is the value for this? So the value for this is firstly this one, which is probability of yes on a sunny weather. Similarly, multiply by the probability of yes. What is the probability of yes? This is the probability of yes. Divide by what is the probability of sunny weather? This is the probability of that. Now press enter. So from here you can see the probability of sunny weather when you will be playing, that is 25%, right? So this is how we have the probability. Now you can see the probability is quite low. That is the reason you're not able to get the proper response. Similarly, if you will have some different values, or if you are checking for some different conditions, so in that case you will be having a different probability. So this is how you can calculate the probability from the Bayes theorem, and this same Bayes theorem we will be applying in the algorithm while we will be doing the coding stuff. So this is how we can do it, right? So now I hope you have got the understanding for the Navier theorem and the Bayes theorem, like how exactly it is working. So the same thing we have to do in the practical part now. Now let's go there and let's understand how to do it practically, right? So let's understand that. Alright, so you can see we have this data with us. This is the program which we have created last time for the KNN. Now let's create a new script, and in there we will be creating a new program. Let's say Navier algo, right? So this is a name of my script. Now for understanding this part, for understanding the Navier's theorem, firstly what exactly we require is we require some data on which we will be applying this classification part, right? So for that, firstly the first important thing is to collect the data, and currently I'm having the data in the sklearn. So the data which we use in the previous step, like in the k nearest neighbor, I will be using the same data so that I don't have to do much stuff on that, right? So let me just copy this much data directly, so I can directly use the same data over here as well, right? So this is what I've done, and I think I have already explained all of them in the previous video. If you're not aware of that, so you can check that video and you can come back here so that it will be clear to you. But for the short introduction, I will say that this is a data set for a flower prediction, where you have a different data set for the flower data, and accordingly you are doing the predictions on that. Last time we have done this part with the KNN model, but this time we will be doing it with the Navier theorem. Alright, so you can see in here that we have the data now. Now for that, firstly I have to import the model which I'm going to use. So let's say from sklearn dot tree import from sklearn dot Navier import Gaussian NV. So this is what we have to import, and based on that we will be creating a model, right? So for that, let's create Navier theorem. So I'm creating a model for that. So I will be calling this class Gaussian Navier. So I will be using the by default feature right now, and after that I will be using the model which I just created, and with that model I will be doing the prediction, or let's say I will be doing the training on that model, and then I will be doing the prediction for that. So nv dot fit, and currently I'm having both the data. Firstly I'm having this, so just type this one input comma, second one is output, just add this, right? Now let's run this part up to this step so that we can verify that it's not giving us any error, right? So let me just run it. Alright, so you can see I didn't get any error. That means everything is perfect. Now we can further do the prediction part on that, right? So let me just show you how to do that. So for that, let's say, so for that just simply type nb dot predict, and in here you have to pass the data which you want to check for. Currently I'm going to pass any random value based on which it will do the prediction for that. So let's say it's like 4 comma 5 comma 2 comma 3. So this is a value which I have specified in here, and based on that it will do the prediction on it, right? So this is all that I have done. Now let's run it again. So you can see iris data prediction, and you have the value as 2, but currently as you can see I have the number but I don't have the name for it. So you already know like how we can check the name for it. So it's like let's say iris dot target underscore names in the square brackets, just put this, right? So now it will show you the name as well. So let's run it now. Okay, so can you see, this is how we have the iris data part over here, and you have the predicted value over here, right? So this is how we can have the results, right? So this is all about it, and I hope you have got the proper understanding for this. But still, if you are facing any difficulties in understanding this topic, feel free to leave a comment below in the comment section. And also, if you are new to our channel and if you haven't subscribed to our channel yet, do click on the subscribe button, and also you can press the bell icon if you don't want to miss any updates from our channel. So till then, bye bye and happy learning.